So now we're going to talk about how to find residuals when you're given data. And they can give you data in a couple different ways. They can give you the data written in a table form. They can give it to you written as a graph. They can give it to you just as raw data, like you could be collecting data for something and be just kind of looking at your data in general. And so what we're going to spend some time doing in this video is talking about how to find the residuals no matter how you're given the data, okay? So just to kind of review, a residual, remember is in general, you're trying to find how far your predicted values are, what you would think would happen, how far those are from what actually happens, okay? So the first thing that you need to know is whenever you actually do the experiment or you're doing something and you're getting your actual values, like what actually happens, they call those your observed values, okay? And so the first thing that you actually have to do is find two things. You have to find what the observed value is, and then you have to find what the predicted value is, okay? Because remember, you're finding how far those two things are apart from each other. So when you have to find residuals from data, the first thing that you want to do is find your observed Y value, what actually happened, okay? So if we were looking at example number 1, it says find the approximate value of the residual for the year 2013. So that means in this problem, you're only concerned with 2013. So the first thing that you're going to do is you're going to find out what actually happened that year, okay? So the observed value is the actual value, what actually happened, not what you predicted would happen, but what actually happened. So you're going to look at your data, okay? So this is the data that they found out. These are the things that actually happened, okay? So you get those values from your table or your graph or however they've presented your data. So all I have to do is look at my table. So I'm going to look for 2013. And in 2013, the value was 32. Now, they're not giving us a whole lot of information about what these numbers actually mean. It could be dollars. It could be a value in some other way. But all we know is the value in 2013 was 32. So we'll act like it's dollars, okay? So the value was $32 in the year 2013. That is my observed Y value, okay? So I'm just going to write that down. So the observed Y value was 32, okay? So what you have to do, remember, to find the residual is you're going to have to take that observed Y value and you're going to have to subtract the predicted Y value. So how do we find the predicted Y value? Well, that's where you had to actually use the line of best fit. So that's the next thing we do. So the first thing, find the observed Y value, and you just get that from the table or the graph. And then you're going to work on finding your predicted Y value. And this is where Desmos comes in, okay? So you're going to pull up the Desmos app on your phone, or you could click on that link in Canvas and pull it up. But you'll pull up Desmos, and you are going to type in your data, and you are going to find the line that best fits your data. Okay, so now notice I have already typed in my data here. And so I'm ready to find the line of best fit, okay? Something that we didn't get to talk about in the last problem is what happens if they're dealing with a year and they're telling you to write the table in a different way. For instance, what if in this problem, so I'm going to move this just for a second, instead of having the years like this, what if they say they want you to write the equation in the years since, like for instance, 2000. So then what you actually have to do is go to your table and rewrite these numbers, because instead of just entering them as the years with how they look, you're going to have to think about, okay, if we have to enter these in as the years since 2000, we have to figure out how far each of these years are from this year. Well, how far is 2010 from the year 2000? Well, it's just 10 years away. And so then, okay, how far is 2011 from the year 2000? Well, that's 11 years away. And so you're going to go through, and for each of these years, you're going to figure out how far it is from the year 2000, okay? So you would enter these numbers in instead of the actual year, okay? So what I'm going to do is I'm going to go back through, and I'm going to change each one of these to those new X values. Okay, so you just go back through and type it in as how many years it's been since the year 2000, okay? And so that will change your equation. So if they are asking you to find an equation and they say something like this, you have to go in and do that, okay? And then like I said in the other video, if they don't tell you you have to do that, you can just possibly enter it in exactly how it looks, okay? So once you get those in, you are going to use Desmos to find the line of best fit. So this is what we did in the last video, okay? But you press the little plus sign, you press expression, and then this is where you type in the Y with the little squiggly. But you remember, you have to make it match your table. So since there's a Y1 up here, when I type in my Y, I'm going to have to put a 1 with it. And then you do little squiggly, which is your tilde. So press the squiggly, and then it's MX. Then you have to type a 1 with the X. And then plus B. Okay? So once you get that in, it's going to do two things. Well, when you type in your data, it's going to plot a scatter plot for you. So I'm going to look at where my numbers will be, and I'll have to zoom out. But notice it plotted the points for me whenever I entered the data, and then whenever I brought up the line of best fit, it went ahead and put the line of best fit on my graph, okay? So from there, you are going to look at what it gives you, and you will write down the equation of the line that best fits it. So my M is 6, so it's going to be Y equals 6X, and then my Y value is negative 44.8. And so remember, this equation is based on these numbers that I've typed in. If I typed in the years how they looked, that equation would be very different looking, okay? And so just make sure you know that, all right? So once you get your equation, you're good with your Desmos for a minute, you can actually find the predicted value. Because remember, the whole reason, or one main reason we make lines of best fit is to predict things. So what we actually have to do is find the predicted Y value that goes with this year 2013, okay? So remember, your X values in these problems are the years, and then the Y values are the value that it was. So I guess that would be dollars or something, okay? So what we're talking about is the year 2013. So what you have to do is figure out what is the value that year, or what would you predict it would be, okay? So to find the predicted value, we go to the side and we plug in the year 2013. Now here's the catch though. Remember, we entered our value in, or our X values in as how far since to the year 2000. So when I plug in for X, I have to think about, well, how far is this year from that? And it's 13 years, so I'm going to plug a 13 in here. So you're going to take your equation, and you're going to plug in whatever value you're looking for. So we're looking for 2013. Okay, so all I'm going to do is take that, plug it in the equation just like that, and then you can use Desmos or a calculator to type that in. And so when I type that in, my Y value ends up being 33.2. So when you use the equation, the line of best fit equation, what you are doing is finding the prediction at that point in time, okay? So this would be the predicted Y value. So we would think, based on the line of best fit, that in 2013 they would have made $33.20 or something like that, okay? So once you get those two things, once you get the observed and the predicted Y values, to find the residual, all you have to do is subtract them. So make sure you take the observed Y value first. So it would be 32. So we're finding the residual. So you take 32 minus the predicted, which is 33.2. Okay, and then from there, you just subtract those two. And so I end up getting negative 1.2. Okay, so what does that number mean? Well, remember, we took what actually happened and subtracted what we predicted to happen. So there's two ways of looking at that. What actually happened was below what we thought would happen or what we predicted to happen, or we predicted to earn 1.2 more than what actually happened, which if you're predicting to earn more than what actually happens, that may not be a good thing, okay? And so the value, the observed value, what actually happened was 1.2 below what was predicted. So if it's negative, that means that what actually happened was lower than what we would predict to happen. Okay, so that's the process. You start by finding the observed from the table. You use Desmos to find the line of best fit, and then use the line of best fit to find the predicted value, and then you subtract the observed minus the predicted, okay? So let's do one where it gives you a graph, okay? So if it gives you a graph, then you're going to have to take your data from the graph and put it in Desmos. So for me, it's always helpful to write it as a table. So we're comparing the day with the sales. So I'm just going to take those coordinates and write it out. So when I do that, I've got a point at 1:30, a point at 2:15, then we have another one at 3:60, and then at 4:60, and then another one at 5:90. Okay, so I'm going to go ahead and write down my observed value because that one's the easy one because you just have to read the graph. So we're looking at the residual for day 3. So we're only concerned about day 3. So what were our actual sales on day 3? Well, if I look at my graph or if I look at my table, I had $60 in sales. Okay, so what we have to do now is find what would we predict would happen based on the data that we've had, based on the line of best fit. What would we have predicted would happen on that day? Okay, so you pull up your Desmos app, you type in your table. So let me clear out these other tables here. Okay, so let me put that there. So you press the plus. Let's see, because it's kind of hard to see. There we go. Then you go to table, and then you enter your data. So we had, and I'll just enter it to the side here. We had 1, 2, I'm entering my days. And then day 5. And then for the sales, you would enter the 30, the 15, the 60, and then another 60, and then the 90. So this would be what your table looks like. Okay, and then notice it's going to go ahead and graph the scatter plot for you so you can see how well your points form a line, which they're not exactly a line, but they're kind of close, all right? And then you'll pull up your expression, okay? And actually, let me put it below. There we go. And then you'll type in, you're finding the equation of a line. And again, it has to match your table. So my table has a y1 and an x1. So I'm going to type in my y1 and x1 when I do it. And then it's mx1 and then plus b. All right. And then it's got my m and b. So I'm going to write down my line of best fit. And notice it went ahead and graphed the line that goes through it. And so my line was y equals 16.5x. plus 1.5. I just plugged in my slope and my y-intercept, okay? So we're going to use that to find what we would predict to happen on day 3. So notice your x values were your days, And so we're going to plug in a 3 right here to find what we would make in sales, or what we would predict we would make in sales that day. So you take your equation, and instead of the x, you're going to plug in that 3, and then find your predicted y value. So grab your calculator, type in that equation, plugging in 3, and we end up getting 51. So based on my data, if I was just using that line that best fits the data to make a prediction, I would predict that I would end up making $51 in sales on day 3. So the fact that we made $60 is actually a good thing if you're a salesperson, okay? So to find the residual, all you have to do now is take the observed, so the 60, and subtract the predicted value. So 60 minus 51, we end up getting 9. So remember, you're taking the observed value first. So what actually happened was higher than what we would predict to happen. So you actually earned, so we could say that you actually earned $9, if that was dollars, more than what you predicted. What we predicted. So that's how you kind of interpret those numbers. Ooh, got to fix that in there. What we predicted. Okay, so that is how you find the residual when you're given data.